So welcome back. So in this final part, I'd like to say something about the algebra of limits for sequences of vectors. So this is actually simpler than algebra of limits for sequences of real numbers, namely because there's only two of them in sequences of vectors, because you can't multiply two vectors together and you can't divide one vector by another. So the only two things that we've got to look at are if you have two sequences of vectors and you add the two of them together, what happens there? And if you have a sequence of vectors and you scalar multiply it, what happens there? So let's start with addition then. So let's say that we have a sequence X of vectors that converges to the limit vector, which we'll call L. And let's say that we have a sequence Y of vectors that converges to limit vector K. What we then want to ask is if we add the two sequences together, which means term-wise, does the new sequence that we've produced, the sum of the two old sequences, does that converge? And in particular, does it converge to the limit vector L plus the limit vector K? And the answer, of course, is yes, but we want to see why. So firstly, just to make absolutely clear what I mean by the sum of the two sequences. So here is the X sequence where each term is a vector. Here is the Y sequence where each term is a vector. And then the new sequence, the sum of the two old sequences, you add term-wise. So you add this vector x1 to this vector y1. So x1 plus y1 is the first term of the new sequence. Then you add the two second terms together as vectors to get the second term of the new sequence. So it'll be x2 plus y2, and you continue on in this manner. So this forms a new sequence of vectors, and we want to know, does this converge to a limit vector? So to prove this, we don't actually need to use the epsilon definition at all. We can use what we've already shown about coordinate sequences. So this sequence will converge if all of the coordinate sequences converge, and it will converge to the vector that you build out of the limit of all of the coordinate sequences. So let's just think about what the coordinate sequences are going to be. So let's write out this vector sequence in full, where you write out the vectors with all of their coordinates. So here it is. This is the first term here written out in full gory detail. So its first coordinate is x11 plus y11. Then the second coordinate is going to be x12 plus y12, and then it will go all the way down to x1n plus y1n. And then the second term here is going to be, here is its first coordinate, x21 plus y21. Here is the second coordinate, which is x22 plus y22. And here is the nth coordinate, x2n plus y2n. And that, of course, is the case because this is the definition of how you add vectors. You add them coordinate-wise. So here is the y1 vector written out with all its coordinates. Here is the x1 vector written out with all its coordinates. So when you add the two together, you just add all the coordinates, so you get this thing, and the same for this one. So the question is, do the coordinate sequences that we're going to get here, do these converge? And you can probably see that the answer is going to be yes, but let's just work through it. So we know that the x sequence of vectors converges to this limit vector L. That means that all of the coordinate sequences converge, and they converge to their corresponding component of L. So writing that out, here's the first coordinate sequence from our x vector sequence. So I've put in coordinate 1 here for all the terms, and that converges to L1. And then you could have the second coordinate sequence that will converge to L2, and then we go down to the nth coordinate sequence here, so x1n, x2n. This sequence will converge to Ln, where that's the nth coordinate of the limit vector L. Similarly, because the y sequence is a convergent sequence of vectors to the k vector, all of its coordinate sequences must converge, and they must converge to the corresponding component of the k vector. So here is the first coordinate sequence of the y vector sequence. So y11, y21, so we've fixed 1 here, and continuing on, y31, y41, etc. This sequence converges to k1, the first component of the k vector. Then you could have the second coordinate sequence that will converge to k2, all the way down to the nth coordinate sequence, y1n, y2n, y3n, etc. This converges to the nth component of the k vector, kn. And now what you can see is that each of these coordinate sequences in this vector sequence that you got from adding the two vector sequences together, each of those is a sequence of real numbers that you get from adding together two of these convergent coordinate sequences. So for example, the first coordinate sequence here, this as a sequence of real numbers comes from the sum of the first coordinate sequence of the x sequence and the first coordinate sequence of the y sequence. And these are both convergent sequences of real numbers, so we can now apply the algebra of limits that we know applies for sequences of real numbers to say that that sum sequence is going to also be a convergent sequence, and it's going to converge to the sum of the two limits. So it will converge to L1 plus K1. So that's the first coordinate sequence. The second coordinate sequence, again, it's the sum of two of these coordinate sequences. It's the sum of the second coordinate sequence for the x sequence of vectors and the second coordinate sequence for the y sequence of vectors. And both of those are convergent sequences of real numbers. So again, that sum of those two convergent sequences of real numbers is also going to be a convergent sequence of real numbers, and it will converge to the sum of the limits. So it will converge to L2 plus K2. And this will continue on all the way down to the nth one, which will be the sum of these two sequences, the two nth coordinate sequences. Both of those are convergent, so this sum will also be a convergent sequence of real numbers, and it will converge to Ln plus Kn. So all of the coordinate sequences of this sequence of vectors do converge, and therefore the sequence of vectors does converge, and it converges to the vector that you would get by putting together all of the limits of the coordinate sequences. So that's what I've done here. Here's the limit of the first coordinate sequence, which is L1 plus K1. Here's the limit of the second coordinate sequence, which is L2 plus K2, all the way down to the limit of the nth coordinate sequence, which is Ln plus Kn. So that is going to be the limit vector for my sequence of vectors, but you can see that this is just the limit vector L plus the limit vector K, and therefore my sum of these two sequences of vectors does indeed converge, and it converges to the vector sum of my two limit vectors. So that's the addition result done. Let's now move on to the scalar multiplication result. So let's take then a sequence of vectors that converges to a limit vector L. Let's take some real number lambda, and then let's take the sequence that you get by scalar multiplying the original sequence by lambda, and then we want to ask, does this sequence converge, and does it converge to lambda times the limit vector L? So again, just to make absolutely clear what scalar multiplying the sequence means. So if this is our original sequence of vectors x1, x2, x3, then the scalar multiple sequence by lambda means take each of the terms of the sequence and scalar multiply them by lambda. So this is the new sequence I get. Lambda times x1, lambda times x2, lambda times x3, etc. And we're asking, does this sequence converge? And again, we're not going to need to resort to the epsilon definition. We can do this in terms of coordinate sequences and the algebra of limits from sequences of real numbers. So again, this sequence will converge if all of its coordinate sequences converge as sequences of real numbers. So let's write out this sequence in full so that we can see all the coordinates of the vectors. So this first term then, firstly writing out the vector x1, here it is. x11 is the first coordinate, x12 is the second coordinate, x1n is the nth coordinate, and then we're multiplying this vector by lambda, and of course scalar multiplication means that you multiply each of the coordinates by this real number lambda, and this is just multiplication in the real numbers then, because each of the coordinates is just a real number. So that's the first vector of this scalar multiplied sequence. And then here's the second term. So again, this is the coordinates of the original vector x2, so x21, x22, all the way down to x2n, and then scalar multiplied by lambda, you just multiply all of the coordinates by lambda, and this is what you end up with. So now we ask, do these coordinate sequences that we've got here, do these converge? And you can see that the answer is yes, because we know that the coordinate sequences where you take away the lambdas converge. The first coordinate sequence converges to L1, the second coordinate sequence converges to L2, all the way down to the nth coordinate sequence converging to Ln. And then all you've done to these sequences of real numbers is multiply through by a constant. And from the algebra of limits for sequences of real numbers, we know that when you do that, you end up with another convergent sequence, and it converges to that constant times your limit. So this new coordinate sequence that we've got here is going to converge to lambda L1, this one is going to converge to lambda L2, all the way down to this one converging to lambda Ln. So because then all of the coordinate sequences converge, that then implies that your sequence of vectors converges, and it converges to the vector that you get by building, by putting all of the coordinate sequence limits together. So it converges to lambda L1, lambda L2, all the way down to lambda Ln, which is all of the coordinate sequence limits put together as a vector. And you can see that this vector is just lambda times your original limit vector L. So indeed, yes, this new scalar multiplied sequence of vectors does converge if the original sequence of vectors converged, and it converges just to lambda times the limit of the original sequence of vectors. So that then concludes the second of the two algebra of limit results for sequences of vectors. So with that, we'll finish the video here. Thank you for watching.